YOLO everyone, welcome to YOLO Learning. So this is a skill 2 in trigonometric function, and we're going to deal with something called the sinusoidal function, which involves a sine and cosine function. The reason why I said sinusoidal function could be either of sine or cosine function is because that sinusoidal function, which is a periodic function by the way, can be represented in either of sine function's equation or cosine function's equation, and you will see more in detail. Now the transformation part, I will put it in the skill 3 because it's a little lengthier than the skill 2. And when I combine it, it's going to be too long for you to watch it. So let's take a look at this. Now, the pink circle, you've seen this before in the previous unit. This is a unit circle basically. And we have a terminal arm. In gray, we have blue, which is the initial arm. And what I'm going to do is I'm going to rotate this to the counterclockwise, which is the positive angle direction. Let's actually see what happens to the graph on the left side, which represents the y value of the terminal arm. So the x value on the left side, or the graph on the left side, is the angle obviously, because you're basically just keep rotating. And the y value of the graph on the left side is basically the same y value of the unit circle or the terminal arm on the right side. So as you can see already, since it's rotating, the graph goes up and down with the constant max value and a constant minimum value. And hopefully you see it that when it starts from the initial arm and then it goes 90 degrees, 180 degrees, 270, and then comes back to 360, the y value on the left side's graph come back to whatever the starting point. I'm not going to say it comes back to the 0 because it's based on what you see. So let's then take a look at the actual example of this, because you've seen this a lot in real life and you may notice it, you may not notice it, but it's okay. One of the most used example is the sound wave. You've seen a sound wave going up and down all the time, and that's basically one of the examples of sinusoidal function. And let's take a look at this one. So I have a metal ball or some sort of a blue purplish ball attached to the spring, and I will drag the spring or the ball down and I will let that go so that it bounces. Let's actually see what happens. Okay, so I'm going to do this. Let's play, and it's going up and down and up and down, right? So this type of motion can be also represented in sinusoidal function, and this is quite critical because in real life a lot of things can be represented in a pattern, and those patterns can be used to analyze what's happening or what may happen if we change certain factors. So it's quite critical. Hopefully you can make better connection to the trigonometry and trigonometric function to the real life because of these real life examples. So let's take a look at the basic characteristics of the sinusoidal function, and those are very simple. I'm going to go quite quickly on those. So here is the sine function. We're just going to focus on the sine function and the cosine function. We're not going to deal much with the tangent function. So for the sine function always, and you have to remember this, always starts from the origin. Think of that way. Or you can say it always starts from the intersection point with the equation of the axis of symmetry, which is the middle line. And once it starts, it goes up to the max and comes back down to the EAS and go further down to the minimum and comes back to the EAS. So that's the pattern. That's the one cycle of the sine function. So middle, up, middle, down, up. Okay, or middle, max, middle, min, middle. Okay, remember that. Now the period, our starting point is at 0. Our ending point is at 360, so that is 360 minus 0, which is then 360 degrees. Then the amplitude is the distance between the max and the middle, or the minimum and the middle. And in this case is the distance, let's say for example right here or right there, and which is 1, which also can be represented in the form of maximum minus minimum divided by 2, which is 1 minus -1 over 2. Now, I forgot to mention it, but the maximum of sine function's value before any transformations is 1. Minimum is -1. Okay, you have to remember that. Starting point from 0 degrees is just 0, 0. So the x value is the degrees, so it's 0 degrees, 0, but I will omit the degrees from now on. The ending point is then 360 degrees, 0. Equation of the axis of symmetry is the middle line, as I said. Therefore, it's the average of maximum and minimum. Therefore, it is 1 plus -1 divided by 2, which is then 0. However, this is an equation. Therefore, it's a horizontal line, and the equation of a horizontal line is just the y equals a constant number. In this case is the 0. Now, the key points are the points where the graph turns its direction, increasing or decreasing direction, or where it actually intersects with your EAS. In this case is the x-axis without any transformations.
So that will be 0, 0, 90, 1, 180, 0, 270, -1, and 360, 0.
It comes back to its original position. So that's basically sine. Your cosine function looks pretty similar to the sine function, and they actually share quite a lot of characteristics. So let's take a look at the cosine function, and hopefully notice your maximum in a cosine function is +1. Your minimum cosine function is then the -1, basically the same as the sine. One thing that you have to remember for the cosine is that the cosine starts from the max. Okay, so it always starts from the max, whereas the sine started from the middle, and then from the max it comes to the equation of the x's, and then comes down to minimum, comes back to the equation of the x's, and comes back to maximum. So that's basically one cycle, and the period is the same, 60, subtracting the ending point, starting point which is a 0, therefore the period is then 360 degrees. The amplitude is from the middle, which is a 0, right? The middle between the 1 and -1 is a 0. So the distance over there or the distance over there, and that's 1. And same equation as previous one, the maximum minus minimum divided by 2. Starting point here is 0, 1, and the ending point here is 360, 1. Equation of the x's, which is the middle, which is the average, so maximum plus minimum divided by 2, which is then y equals 0. Don't forget the y equals, it's an equation. And the key points the same way, turning points, and where it intersects with the EAS.
So 0, 1, 90, 0, 180, -1, 270, 0, and then 360, 1. So those are the 5 points and then done.
What I'm going to do is I will highlight the characteristics that they share, and they are the period, the amplitude, and the EAS. So these three, the sine function and cosine function, they are exactly the same all the time. Two only differences: starting point and ending point, and the pattern. So sine function goes up to the max right after its starting point, whereas the cosine function, you go down. Well, cosine function is kind of obvious because you're at the max, so the only way that you can come or go is coming back down to the minimum and then go back up, right? So that's the basics of the sine and the cosine function. One thing that is very critical for later on is that you should know how to convert sine function to the cosine function to the sine function. And I can explain this using a graph over here. This is our EAS, y equals 3, and if you take a look at it very closely, our sine can start from this pink point over here. So this is for the sine, whereas my cosine starts from here. That's my cosine start. Oh, by the way, if you're not sure how come the cosine could be on the same graph as the sine, well, the cosine is right there, basically is repeated, right? And the sine can then be this way, can then be that way. So on one graph can have both sine and the cosine function. Now, another thing that I actually forgot to mention from sine and cosine is that sine graph has 5 key points, and because it has 5 key points, which equally divides that one cycle, it divides the cycle in 4 equal length segments. And same thing goes for the cosine. That's 90 degrees, 180, 270, and then 360. So each segment is 90 degrees in this case. It's all 90 degrees. If you take a look at it more deeply, this 90 degrees is just 1/4 times the period, which is 360, which I can say is period over 4, or quarter of a period. So one segment is quarter of a period. And let's take a look at this graph using that knowledge. So my points are all these. Something will be over there too. But let's just take a look at this. If I want to switch my sine function's equation to the cosine function's equation of that same sinusoidal function, all I need is to change the starting point. And because we have the same period, same EAS, and same amplitude, it will not distort the whole graph. It will just move the segment to, or the cycle to the left or to the right. So from sine to cosine, to change my starting point, all I have to do is I have to just move the sine starting point to the cosine starting point by 90 degrees or a period of 4 to the right. And then cosine to the sine is then 1/4 of the period, now then going back. So going to the left. As long as you remember this, it will be quite easy later on when you're dealing with word problems or transformation. Helpful. Hopefully you guys enjoyed watching the video and it was beneficial to you. Thank you for watching YOLO Learning. I will see you guys in the skill 3, the transformations. Bye bye.